First of all, I would like to say good morning, good afternoon, teacher. So my name is Obutirat, and today I'm gonna talk about uh, CPU metric with top. Okay, so to start off with, the first one is the system time. So as you can see here, we're gonna use this command to see this output. So when I run this command, so the dd, which means this is a called Linux utilities used to convert and copy files, because everything in the Linux is treated as a file, and it can copy data from hardware devices or special system streams. And for this part, if equal to /dave /urandom here, so this sets the input file. So uh, /dave /urandom is a special file in Linux that serves a pseudo random number generated managed directly by the kernel. So for the off equal the /dave /null, so it sets the output file. So slash null slash /dave null is a virtual device often called the black hole. It's instantly discard any data written to it. So the CPU is forced to constantly request random numbers from the operating system kernel, because the kernel have to actually work to generate the random stream for every block of data. So the CPU spend its cycle running the kernel level code rather than the standard application software. So moving on to the second one is the idle time. So as you can see here, so when a system is quiet, the Linux operating system scheduler has no processes waiting in its execution queue. So when the operating system has nothing to process, it executes special low power idle tasks or send a specific instructions to the CPU. So this puts the processor into a dormant state to save it can save power, lower your temperature, and until a new hardware or software interrupt occurs. Okay, for the third one is the user time. So we use this command, the SHA-256 sum here, you can see here. So this is the output. So the SHA-256 sum, this is a utility that calculates a SHA-256 cryptographic hash, so of whatever data you feed in. It uses a mathematical signature, complex mathematical signature. So for the Dave 0 here, this is another special file that provides an infinite stream of nulls byte zeros as fast as it can be read. So the SHA-256 sum program takes an endless stream of zeros and continuously runs intensive mathematical encryption algorithms on them. This math happens entirely inside the user applications layer, meaning CPU is doing heavy calculations without needing to jump back to kernel mode or to handle hardware or system management. So the fourth one is a nice command that we're gonna use to run so that we can see this output. So the nicey is the utility it used to alter the scheduling priority of a process before you run it. So the -19. So these are the nicest level to +19. So in Linux, niceness ranges from -20 to 19. Yeah, and for the SHA-256 sum, Dave 0 here, this is the exact same math heavy user space command from TAT3 that I've talked earlier. The workload is identical to TAT3, but because you explicitly told the system to run with a nice value, the Linux kernel tracks its CPU consumptions under the dedicated bucket instead of the standard US user time. So this tells the system administrators that a low priority background task is utilizing the CPU. So last but not least is wait time. So this is the command that we're gonna use to run it, and this is the output. So the DE is just the same for copying. Is it a copying tool? If they've 0 here, the input file provided an stream of 0 of equal testing here. Testing here, testing mg here is to create an actual output file named test img image right on the local storage device. bs equal 4k, count equal 100,000. So this tells DD to write the data in a small block size block. Yeah, and the flag equal desync is a critical flag. It forces data synchronization, means the system cannot store in a quick temporary RAM cache. It must write in straight to physical storage hardware before processing in the next block. So the CPU process data billions of times faster than the solid SSD or hard drive can write it down, because the desync flags prevent the system from buffering the data in the fast memory. So the CPU finish preparing a 4K block instantly and is forced to idle and wait for the slow storage hardware to finish writing to the physical disk before it can send the next block. Thank you, teacher and everyone, for listening to my explanation from start to the end. Thank you.